We're going to continue looking at lines of best fit and how to use lines of best fit to estimate or predict values. Recall that a line of best fit is a line drawn through data points to best represent a linear relationship between two variables. So here is the line of best fit, and it shows the relationship between the number of games played and the number of shifts per game. We can see it's moving up to the right, so that tells us we have a positive correlation. So as the number of games played increases, so does the number of shifts per game. Also, in a scatter plot, a point that lies far away from the main cluster of points is called an outlier. So we can see the cluster of points here, that there's this point that sits outside the main cluster of points. So that would be an outlier. And outliers will make a difference when trying to determine your line of best fit, and then will affect your predictions or estimates. And finally, a line of best fit can be used to estimate or predict values. Estimating the values that lie among the known values on a graph is called interpolation. So for example, if I take a look at the graph on the right, it's going from my lowest to highest point on this graph, highlighted here in yellow. I can make a prediction. Let's say if a player played 50 games, I could predict that they had about 10 shifts per game. And notice, since this green line falls within our range of points, that would be called interpolation. Predicting values that lie beyond the known values is called extrapolation. So for example, any values that are below the lowest point and above the highest point. If I was to make a prediction, let's say for a player who played 20 games, and look over and say they played approximately 7 shifts per game, that's extrapolation, because I'm trying to determine or trying to make a prediction outside our known range of values. So let's go through an example, make some predictions using the line of best fit, and to determine whether we're interpolating or extrapolating the data. So example 1, we're comparing term marks with exam marks. This is the practice question that we looked at yesterday, and we noted that the term marks will be our x values and the exam marks will be our y, because we said our exam mark would depend on how well we did throughout the term. So now we're going to go to Desmos, we're going to graph the data and add the line of best fit, and we're also going to determine the equation of the line of best fit. So notice the instructions are here below. I'm going to go to Desmos now, go through all the steps we did yesterday, and talk about the new steps today. Alright, once you get to Desmos, the first thing to do is to add your table. Next is to type in all your data values. Recall, if we want to see all our data points on the graph, we click on the Zoom Fit icon over here on the bottom left. And notice we have a positive correlation. As the one variable increases, the other increases. Next, we're going to include our labels for the x and y axis. So go over to our graph settings. Click on our graph settings again to close the menu. And notice now we have our titles, exam mark, and term mark. Next, we're going to add our line of best fit. So it's going to be y, and then we go to our subscript. 1, hit the right arrow, hit this wave or the tilde button, then A, X, subscript, 1 again, and hit the right arrow, and then plus B. And notice there is our line of best fit. When we do this, we also found the values for A and B. which are shown here where the word parameters are. We can see them down here at the bottom. We see A is decimal 906,339 and B is 6.88038. So those are the values we're going to use for our equation of best fit. So now let's go back to our note. So we used Desmos to determine our line of best fit, and when we did so, it gave us our parameters for A, 0.906339, and our value for B, 6.88038. So the equation for our line of best fit, so we end up with y equals 0.906339x plus our B value, which is 6.88038. There's our equation of the line of best fit. Remember that x represents the term mark in this equation as a percent, and y represents the exam mark as a percent. So let's make some predictions. Use the line of best fit to predict the exam mark of a student with a term mark of 98. Remember that the term mark that we have here is our x value. So using Desmos, remember we're going to let x equal 98%. So recall in Desmos, we add a new item, and we're going to say that x is equal to 98. If we hover over the item and click on it, we see that if a person had a 98% term mark, their exam mark would be 95.7, or it's estimated that they would have an exam mark of 95.7. So therefore, a student with a term mark of 98 is predicted to have an exam mark of 95.7. Does your answer represent interpolation or extrapolation? So let's go back to our graph. Notice that point is just outside our range of values. It's close to it, and if you look at our table of values, there's no one with a term mark above 95, so 98 is above our data set of values, so therefore this is called extrapolation. A second way to do this now is to use the equation. So recall from above that we said that y was equal to 0.906339 x plus 6.88038. Same as what we did using Desmos, we're going to let x equal 98. So in our equation, we're going to get y equal to 0.906339 times 98 plus 6.88038. Next, we use our calculator, and we get approximately 95.7%. So we'd have the same conclusion as we had on the left, as well as this is still extrapolation because our 98% is outside of our data range. All right, last one. Use the line of best fit to predict a term mark of a student with an exam mark of 85%. So this time we're given the exam mark, and recall that is a y value. So we're going to let y equal 85. So we're going to do this using Desmos and then do this using the equation. So recall in Desmos, we're just going to type in y equals 85. And hit enter. We're going to go to that point of intersection of the y and line of best fit. Click there and notice it predicts that if we had an exam mark of 85, that our course mark was approximately 86.2%. So going back to our note, if we let y equal 85, we can say then a student with an exam mark of 85% is predicted to have a term mark of 86.2%. This one is interpolation. Since 85% falls within our data range. Next, we can also use the equation. So same as before, we're going to let y equal 85. So we start off with the same step. Then we use our line of best fit. So we have 85 equals 0.906339x plus 6.88038. We're isolating for x, so our first step is to minus the 6.88038 from both sides. And that gives us 78.11962, which equals 0.906339x. And our last step is to divide both sides by 0.906339, 0.906339. Those cancel. And we're left with x approximately equal to 86.2%. And our same conclusion, a student with an exam mark of 85% is predicted to have a term mark of 86.2%. And this prediction uses interpolation since 85% falls within our data range. Right, so there's a caution here. Of these two methods, interpolation is always preferred. This is because we have a greater likelihood of obtaining a valid estimate. So if you have data points and you're checking and you're estimating within those data points, we can say that it is probably true. However, when we use extrapolation, we're making the assumption that our observed trend continues for values outside the range we used, which may not be true. So we just need to be careful when using extrapolation. There are the questions that you can try.